A basic example of discrete probability distributions is working with a weighted die. In this scenario, x will represent a random variable for the sides of the weighted die, and p of x represents the probability that the side will land facing up. We want to find the mean and standard deviation of this distribution. The first thing we need to do is actually verify that the probability distribution is valid. If the distribution is not valid, we cannot find the mean and standard deviation requested. The first step in verifying the validity is to check to see if all of the probabilities are between 0 and 1 inclusive. This is a visual check. If you look through all of the probabilities shown in this table, all of them are a decimal value between 0 and 1. So our first requirement is met. Our second requirement is to find the sum of the probabilities. These need to be equal to 1 or very close to. We're going to add up all of the values in the probability column. When I add up all of the values in the probability column, I get that it is actually equal to 1. So yes, my probability distribution is valid, and now I can move on. Using my 1VAR calculator feature, in the list, I'm going to enter the column that is the sides of the weighted die, and in the FREQ list, the probability of each of those happening. The only values we have are 1 through 6 because we have only 6 sides of the die. So the values for x represent all of the possibilities for all of the outcomes of this potential scenario or this procedure of rolling the die. Verify that the values in each of your lists are correctly matched up. And remember that when you are describing what is in your 1VAR stats on the list in FREQ list, to not tell me L1 or L2, but to describe specifically what is in those values. However, be sure to note on your own paper which values are in which list. When you complete the calculators, notice that x bar is 3.4. X bar in this case represents your mean. However, because we are looking at all of the possibilities of the weighted die, your mean is representing the total population. So we will have to change our variable notation to mu instead of the x bar we see on the calculator. Also note that we have our sigma x on the calculator as this long non-terminating decimal. We still need to remember our rounding rules, which is always one place more than the data given, so we'll need to round our standard deviation as well. Our standard deviation in this case is 1.2. Remember that for mu's and sigmas, x bars or s's, that while your calculator may show an x, you do not add those into your final notation for this class.